Okay, so it's all done. So here's our new thing. And yes, now it's fractured the way it should be. And of course, that all trickles down. Now there's no problem. We can actually just immediately jump back into the sim and see, if I go back into my camera, how that would play out. Now, again, we don't want the helicopter to shatter like this. This is just a proof of concept that things are flowing through. Everything seems to be working correctly. Nothing is holding any of these pieces together right now, but it literally works. Cool. So, one of the main things we would need there, of course, is we want this thing to actually be constrained together. So let's go back over into the frac actually and say, okay, so by here we have our pieces. I'll just go over here. By here we have our pieces. Let's actually unpack them for a minute. And let's take our names with us. So here we go. So we have this. We want to promote our point to our primitives, the names, because we can do this. Connect adjacent pieces. Connect adjacent pieces is pretty great. We used this before. This will determine what pieces are near each other, and it will draw lines between them. And as in the previous lesson, it will create lines where the lines have point attributes, where the point attributes are the pieces that are connected to each other. So any given line has 2 points, and the 2 points have name attributes, and those are the names of the things that are connected. So to belabor this point, I'm going to say, if we chose this piece here, I'm going to do one of these things where I delete non-selected. So we have this one primitive here. It's got 2 points, of course. And if we look at it, we can see it's connecting piece 573 to piece 684. And on the primitive itself is where we'll store the various attributes that we're interested in. For example, I would say if we wanted to do glue, we'll just start out with, we'll call it process constraints. With a simple glue, we're going to need at the very least the constraint name equals glue. And we're going to want to know the strength, which will just start at 1. So now we have a constraint that knows whose it's attached to, and it knows what kind of constraint it is, at least the name of it, and how strong it is in the case of glue. And as is often the case, I like to just keep rest length equals 0. It just makes the constraints work better for reasons that I will not get into right now. And of course, we just don't want the one piece. We want this to do it for everything. So here's lots of things. Now, we have a lot of constraints here. A lot of constraints. In fact, we have 224,000 constraints. That's fine. You can do that, but we really don't need to, especially considering the fact that we only have 2,000 pieces. Why do we need 100 constraints per piece? That's crazy. So there's a much better way. Instead of using adjacent pieces from points, let's do adjacent pieces. And we don't want to do adjacent points either, because when we do adjacent points, oops, keep deleting things by accident. Last lesson, I believe we did do adjacent points, and that made a lot of sense back then. Things were pretty regular. Now we have a pretty irregular looking helicopter. If I say adjacent points like this, no, it doesn't even really want to work. I'm not really sure why, but either way, we can do that. I guess adjacent pieces from points is what we did. This is okay. The problem is that the points that this is referring to, if we're just talking about the packed pieces, are the centroids of the pieces. And that doesn't always work. For example, we have this big tank thing here, an auxiliary fuel thing. It's going to have a point in the middle of it, which is pretty far away from the surface. So here it is. That's the point there that's in the middle of this tanker thing. So when trying to figure out who should be connected to who, the tanker in fact is directly adjacent to this bracket. They're right on top of each other. But from this perspective, they're actually pretty far away because the points represent the centroids. And that's going to happen a lot. So that's not really accurate enough for what we want to do. So all this is to say, let's unpack it, turn it into polygons again. We have our names just to make sure. And this, we'll do adjacent pieces from surface points. Adjacent pieces from surface points is a tongue twister. And what it does is when doing the calculation, it's going to scatter points all over the surface. So if we were to look at this, it's kind of like this. So here's our helicopter. So if you could imagine, it's going to make a representation of the surface out of lots and lots of points like this. We don't even need to relax them. And so by looking at this, it's going to say, oh, look at all these points along the surface of this thing. And then the surface of this bracket points will be close to the points on the surface of this. So it's going to say, oh, look, these two things are close to each other. What piece do you represent based on your name? And then we'll make the constraints point to the center of it. But as you can see, in general, we don't have 200,000 constraints anymore. Now we have 8,000. And we only had 2,000 pieces in the first place. So 4 constraints per piece, yeah, that makes a lot of sense. That's fine. So we don't need to scatter. That was just for demonstration. We can always, go through this and alter it if we want, but this should be fine. We could put like points to 1 here. You might get less constraints by doing that. It might not find as many also. Looks like it's largely the same in our case. I'm just going to leave it at 10 just to make sure it doesn't miss anything. You can increase the search radius, of course, blah, blah, blah. But this is fine. So this is looking pretty good. So again, looking at this, I'm pretty happy with it. I don't see any pieces that are connecting things that shouldn't be connected. Even this is looking good. So I'd say we're fine. So this looks pretty good. Great. Don't need that anymore. Process constraints is doing its thing. And then I can say constraints. And we can point to this. Cool. Great. And because we have our animation again starting at the origin, this thing out here, the heli pieces, it's overlapping. Oh, I guess I'll keep that on. It's overlapping the constraints where it should be. Like that. So that's good. Otherwise, we'd have to, again, transform these constraints into the first frame position, which is up here. And then it's just a pain. So it's better to just do that. To what we're doing, where we have the animation, put it back at the origin in the first frame. So we have our constraints. Let's bring them in. Same way as last time, constraint network. Drop it down. Oh, we're on the second frame here. A lot of times when you're working in your sim area, just turn the sim off so it doesn't keep trying to re-sim everything. It's a waste of time, as you can imagine, to have it re-sim everything every time I just put one node down when I'm planning on putting 10 nodes down. So constraints to create, glue constraint relationship, I'll just call it glue. And also recall that this data name here, this is what is matching up with the constraint type that we set here, constraint name rather. Constraint name is glue. So in the sim, by calling this glue, that's what's making it match up. The strength of 1 is being multiplied by this. In fact, and remember this, every constraint that you can put down in here, whether it's a spring, where are you, spring relationship, or whatever, wherever you see these parameters and see the actual name of it, so this one says rest length with no space and no capital, so it says damping, you can create that attribute on the primitive lines itself. So in this case, that's why, because we have parameter strength here, that's why we were able to, oopsies, That's why we were able to make this strength float. You can do that for any of them, really. If we come back in here again, propagation rate, you could set this, you could set the half-life or whatever. Great. Now this is still erroring because it doesn't actually point to anything. So let's point it to our frac constraints. There we go. Now I will turn this back on, and you can see there they are. There's our constraint relationships. Now we probably don't really need to see that, so I'm just going to turn it off, but it is there. So now let's see what we get from this. Okay, so it's still simming, but this is enough done to look. Bam. Pretty interesting, actually. You can see it's coming in, hitting the ground. I'm going to actually cancel the rest of the sim. We don't really need it. It's staying together this time. Remember the propeller blades had already flown apart the moment it had become active before? So they're glued together this time, and they're staying glued together, and it's still following the animation. And then they kind of freeze up, as you can see here. Because once the sim takes over and they're glued, they're no longer reading the animation. They also can't spin because they're glued together. But anyway, it starts to look nice. The propeller blades break first without the whole thing coming apart. It's still shattering in an extremely unbelievable way because there's no denting or anything or springiness to it. But anyway, it's something. We've got a big chunk of helicopter flying over here, and everything else is completely shattered. But we're absolutely getting somewhere now. Cool.